Hello guys, this is Rakesh from Bodhee Prep, and in this video we'll continue the basics of algebra and we'll try to understand what is function, right? So before we understand the mathematical meaning of function, let us understand what actually functions with the example of real life, right? So let us take an example of say ATM machine. So if I have an ATM machine, we all have used ATM machine to withdraw the cash, right? Withdraw cash. Now what happens in ATM machine is that first of all you put the input. Of course, you first of all put your debit card, etc. Now after that, you put some inputs from the keyboards given there, right? Depending upon the input, what ATM machine does is that it reads your inputs and analyze it and just cross-check various other things like whether the amount is available in your account or not or something else, etc. Some more information is also again checked. After that, it basically gives you cash, right? So this is a simple process happening. Now, if somebody asks you what is the function of ATM machine, right? So what is my answer? Our answer would be the function of ATM machine is to give cash depending upon the input provided after checking the relevant information and after checking the relevant say other conditions, right? So the function of ATM is to give cash. But what is the input provided? The input provided is in the keyboard. So the cash provided by the ATM is directly linked with the input provided, right? It will never happen that you are providing an input of say 5,000 and the ATM is giving you only 500 rupees or ATM is giving you 5,000 rupees, say 50,000 rupees. It will never happen, right? Always, whatever the input is provided, the output will be according to the input provided. Fair enough, right? So we can say that the function is nothing but a set of rules wherein it takes the input, it processes the input depending upon the set of the rules, which is predefined, and then it gives me the output, right? So there is an input which will be processed under certain set of rules, and after processing, we will be getting the output, right? This entire thing is called say function. In mathematics, what happens is that if I say f of x, then we call it as function of x. So if this is a function, it must have some certain set of rules. Suppose I define that the set of rule is that the input provided will be in the form of x or the value of x, but the output should be square of x. The output should be square of x, right? So here x becomes the input, right? What is the rule? Rule is squaring the input. And what would be the output? The output would be the square of whatever the input provided, right? This is the simple correlation between the real life example of function and the mathematical function. Now, since in mathematics, definitely we have to get into the depth of what function is actually. So we'll be studying it in bits and pieces, the every part of the function. So here x, whatever the input is provided, we call it as independent variable, right? The output, many a time it is denoted by y. This is what actually function is. Y is actually equal to f of x, and f of x is defined by certain mathematical rules. Here the mathematical rule is squaring of the input, and whatever the input is taken after squaring it, whatever comes, that becomes the output or the value of y. So the value of y is called dependent variable, right? Now there are certain more terms used in functions. So today's video is all about understanding those terms so that we have a basic fundamental idea about functions. And in the upcoming session, we'll be taking the advanced topics from the function. But for those of you who are very new to the function, the things which I'm discussing right now is very, very necessary, right? So functions has two variables usually. F of x is usually denoted by y, right? And it will have some kind of mathematical operations on the input. I can have a functions like x square plus 3. This is also a function, correct? Now, if x is an independent variable, x will take certain values. Whatever values x can take, we call that as domain of the function. We call that as domain of the function, right? And whatever the corresponding value which an output can have, we call it as range of the function. So what is domain actually? Domain is nothing but all values which we can put as an input. And what is the range? All values which the possible outcome it can have, right? Now, can we have anything which we can put as a domain? Of course not, right? For example, in ATM machine, it has a capacity, right? You can't withdraw more than 20,000 or 30,000 or 50,000, right? You can't put it 10 lakhs there. So we can say that there is a limit of the domain, or there is a limit of the input which we can provide. So domain is also defined or definite in nature. Usually it is definite in nature, right? At the same time, domain cannot be something which will be, applying the rule will be getting something which is not defined, or the range is not defined. We can't have certain domains. So it's not like that if it is called independent variable, that doesn't mean that we can put anything. For example, in ATM machine, if you start putting, instead of number, if you start putting say hexadecimal number, say I'm putting a dollar sign, I'm putting exclamation sign, something like this. So it will not process it because this is beyond the domain of the ATM machine. ATM machine will only take numerical values, right? It will, in fact, within the numerical values, it cannot take negative values, right? It cannot take negative values. So domain is, although X is independent variable, that doesn't mean it can take any value which is possible. It has to take those values for which the output is defined. The output is defined, right? So Y or the range has to be defined, that for those corresponding values of X, we call as domain, right? For example, if I take the function f of X, which is, the rule is that it will reciprocal the input, right? We all know from the number systems that 1 over 0 is actually not defined. 1 over 0 is not defined. So here we will say that X, the domain would be anything, any real number other than 0. So we can say that X will take element which will all real number minus the integer 0. So this is how we will denote the domain of this function. All real values except 0. Fair enough, right? So let us take certain more examples to understand domain in detail. If I have a function f of x, which is equal to say x square plus 1. In this case, if I talk about domain, I should look for certain types of values of x for which f of x will not be defined. X, all positive values, it is defined. X is equal to 0, it is defined. All negative values, defined. X having say fraction, that is also defined. You can put any fraction, be it positive or negative, greater than 1, less than 1, less than minus 1, it doesn't matter. So here we can see that for any corresponding value of x, we will have some definite value of f of x, right? For example, if I take the value of x to be 2, then f of x would be what? Or f of 2 would be what? 2 square plus 1, which will give me 5. It's a definite value, right? Even if I take the value of x to be 0, so f of 0 would be what? 0 square plus 1, which will be equal to 1. Again, a definite value. Even if I take it fraction, so f of 1 by 2 would be what? 1 by 2 whole square plus of 1, which comes out to be 5 by 4. Again, a definite value. I can take negative values also. If I take the value of x to be say minus 2, so f of minus 2 is minus 2 square plus of 1, which will again give me 5, right? And you can try some more values. So you'll find that x can take all real values. So we'll see that the domain here is all real values. Fair enough, right? But if I take another function, say f of x, which is equal to under root of x, right? Under root of x. Correct? Now here, I can't take the value of x to be minus 1. Why? The moment I take the value of x to be minus 1, it will be minus under root of minus 1, right? In this case, the output, the value of the function will not be a real number. It will be a imaginary number, right? So in functions, for cat, we define functions getting real values. So we'll say that domain of the function will not be x equal to -2. In fact, any negative value would be discarded. Correct? So in this case, for this particular function, the domain or the possible values of x would be all real values which are positive, right? It can take negative values also. So in this case, what we can do is that we can define the domain as x will take all element which will be starting from 0, considering 0 also, till all positive values. 0 is also included. We don't have to take negative values. We have to take only either 0 or positive values. So this is how the domain of x will be defined, right? In the same case, if I consider a function f of x which is equal to 1 over under root of x. In this case, we can say that under root of x will give me real value only if x is non-negative, right? But since it is reciprocal, in reciprocal, we know that in the denominator, it should not be 0. So here, the domain, which is the value of x, will be from 0 to infinity, except 0. We can't take 0, but we can take any positive value. 0.0001 will also do, right? Of course, negative value is discarded because it is under root. So you can see that subtly how the functions are given depending upon which the domain also changes, right? Right now, we are not talking about the range, but we are focusing primarily on the domain, correct? So if f of x is 1 over under root of x minus of 1, in this case, we can see that putting value of x greater than 0 but less than 1 will also make this as negative. Unless the value of x is more than 1, this entire thing is not going to be a positive value. So in this case, the domain of x will be what? All values from 1 to infinity. In fact, x is equal to 1 is also discarded because the moment I take the value of x to the x is equal to 1, this will become 0. So overall value of f of x will be what? 1 over 0, which is not defined. Right? Okay. So this is all about domain. So I'm just writing few questions. You'll pause the video and try to figure out the domain of it, right? So the first question here is that if f of x, in all the cases, we have to find the domain. F of x is equal to, say, x squared. You have to find the domain. Next, f of x is equal to 1 over x squared. Third, f of x is, say, 1 over under root of x plus 2. And fourth is f of x is equal to log of x with base 10. Right? Just pause the video and try to figure out that what will be the domain. Okay, I hope you must have done it. So let's try to find the domain. In this case, we can see that no matter what value x will take, x square will always be positive. There is no value of x for which f of x, that is x square, will be a not defined case, right? So we can say that it is nothing but all real values. So if all real values, that means x will take elements from anything from minus infinity to plus infinity. So this becomes the domain, right? Here again, this is a reciprocal. So in the reciprocal, only in the case of denominator being 0, it is not defined. Rest, it is always be a finite value. So in this case, the domain would be from minus infinity to 0, union 0 to infinity. This is how we write it. We are taking all the values in the number line from minus infinity to infinity except 0. Except 0. So what we are doing is that we are taking all the values from here to here, then all the values from here to here, and we are adding it. This sign union is actually what? Addition of this portion and addition of this portion, right? Here again, x plus 2 has to be greater than 0, correct? Now mathematically, if I want to find, right now we are doing by simple observation, but mathematically if I want to find, then what we can do is that x plus 2 for this under root portion to be a real number, we can say that x plus 2 has to be greater than or equal to 0. But since it is 1 over this, then we can say that equal to 0 has to be neglected, right? So we are finding that unless and until x plus 2 is greater than 0, right? Or the function will be defined for x plus 2 whenever it will be greater than 0. So taking minus to both the side will be getting x should be greater than minus of 2. So on a number line, we can see that if this is minus 2, this is plus infinity. So everything from this to infinity will be my domain except the value of minus 2. Because the moment I put the value of x to be minus 2, this will become 0, which we don't have to take. So here the value of x will be an element which is from minus 2 to infinity, right? Next is log of x. Now, in the chapter of logarithm, we saw that x cannot be any value which is negative, right? So log of negative value is not defined, correct? Can x take 0? No, because log of 0 is also not defined. It has to be greater than 0 for sure. So in this case, x will take all values from 0 to infinity, excluding 0, because I'm taking open bracket. I hope you have gone through the video of I think inequalities, wherein I have taken this concept of what is open bracket and close bracket, right? So this is all about domain. Now, what about the range? What about the range? So range, as I say that, what are the possible outcomes the function can have? That is the range. So if I take the similar example that f of x is equal to x square, right? So we are sure that f of x will never be negative, right? F of x can be 0. F of x can be any positive value also, correct? Any positive real number. So here again, the range will be what? It will be an element from 0, including 0 till infinity. So range is also in this particular. So if I compare the range and domain, the domain here was any real value, but the range here is only non-negative real values, right? Because it can't take negative value. It's a square. Second is, if I take say f of x is equal to 1 over x, let us try to figure out what is the range, correct? So here we can say that f of x, can it be 1? Yes, the value of, if I take the value of x to be 1, it will be 1. Can it be 0? Can it be 0? No, but it can approach towards 0. It can approach towards 0, right? So can it be anything which is, I would say, greater than 1? Can it be greater than 1? Yes, it can be, because the moment I say I can take the value of x to be say 1 over 1000, overall value would become 1000, right? So is there any value which f of x can't take? Is there any value which f of x can't take? Then it has to be 0 only, right? F of x cannot be 0, because no matter what value of x you take, it will be 1 over that value. It will be 0.000 something, but it will never approach towards 0, right? It will never be equal to 0. So again, here the range is all the possible values except 0. So we can say that the range would be from minus infinity to 0, union 0 to infinity, right? But if I take the value of f of x is equal to 1 over x square, here we can say that x square being uh, a square of a number, it will never be negative, right? And from this logic, we can also say that it will never be equal to 0 for any possible value of x. Then here the range will be what? It would be all values from 0 to infinity, excluding 0. Right? Fair enough. Now, is there another way of getting the range quickly or mathematically? Yes, there is. Because x and y, they are dependent on each other. X being an independent variable, but still x cannot take any value for which y is not defined. right? And y has to be always a definite value, right? So what we can do is that we can just reverse the position of x and y and apply the logic of finding the domain only. For example, in this case only, if I say that f of x, or let me take the first question, I can take this, make f of x is equal to say y is equal to x. Now, my job is for finding the range, my job is to put everything in terms of x is equal to. So can I say x would be equal to under root of y? We can do that, right? Not just focus on y. Y should take such value so that this is a defined one, real one. This is defined one and real one. You'll always say that y has to be non-negative value. Non-negative value in this is y can take 0, but it cannot take negative value. So y would take all the elements from 0 to all positive values, which is infinity. And that is what becomes the range. Because what is range? Range is nothing but the value of y. What is y? The possible value of f of x. That is what by definition is range, right? Similarly, for next one, if f of x is equal to 1 by x, we can write it as y is equal to 1 over x, or the value of x is equal to 1 over y. Now just focus on this. For which value of y? This is defined. Except 0, y can take any value, right? Except 0, y can take any value. So we can say that y, which is the range of the original function, would be any value from minus infinity to 0, union from 0 to infinity. That is what we are getting here, right? So this is the trick to find the range. Come to this. F of x is equal to 1 over x square. We can say that y is 1 over x square. We can say that x square is equal to 1 over y. We can say that the value of x is 1 over under root of y, right? Now again focus on this and try to think like what could be the domain of y. The domain of y would be that y cannot take 0, right? Otherwise this is not defined. Y has to be always positive. So y will take all the values which is from 0 to infinity excluding 0. That is what we have got here. So domain and range in a function are interlinked. So we have to just focus on finding domain, the process of finding domain. For range, we'll be using this trick that we will replace or we'll just transpose the function from being function of x to being to make it function of y, right?